Hey everyone! Welcome to the first part, well technically second part, but this is gonna be called part 1 because this is the when we actually get into the into what this series is intended for, and now that we're done with the intro, we're going to get into the first thing that we are going to cover. So we're going to start, as many of you may have guessed, with Microsoft Word. Now, today we're going to do something a little bit not expected, because, like, as I pointed out, that we're going to be diving into the different tools and different sorts of technologies available to make maths and science accessible. Now, before we actually get into those, there's some sort of like prerequisites that come in handy for anyone operating said tools, which I figured would be worth showing off to people, because believe it or not, I didn't believe it myself, but there are many people who actually do not make use of these tiny little tidbits or these skills, and they do tend to come in handy quite a bit. So they're basically, like I said, we're going to be using Microsoft Word for this part, as well as quite a few parts from now. And that would be our primary source of learning, because unfortunately right now that's the only good enough word processor that we have, which can work with text as well as maths content. So I'm gonna go ahead, you're gonna need I'm just gonna point this out, and I'll also drop a link in the description later. We are going to need a Microsoft Word 2019, Office 2019, for this to correctly work, because otherwise we will unfortunately go through some challenges later on, especially if we don't have the latest version of Office. So I'm gonna go ahead and use a pretty simple shortcut to open Word, instead of like clicking on different icons, and I just find this faster. And you're gonna hear my NVDA. That's not what I was supposed to do. Alright. Yeah. So there we go. So we have a plain document open now. I'll get into why it says that later in the next part or so. In any case, so we have a plain document open now. So we're gonna start with writing simple numbers. So as I said before, in this part we're gonna cover the basics and some basic skills that come in handy. That for the later tools that we are gonna utilize, the external stuff. But so the very first thing that we're gonna explore is the things that we already have, that we don't need to make an effort for, and that if we don't know, then we should have a good idea of by now. And many of us do, but like I said, I've also seen many of us who do not. So I'm gonna start by entering a simple number. So it says 2, but before that it says page 1 baseline. I'll also go ahead and lower this down. Yeah, so 2. Okay, so that's a simple number. So we can write numbers from 1 to 0. That's pretty obvious. But if we want to represent an equation, for example, with NVDA, so I'm gonna go ahead and write down x equals 2.
Baseline.
Right. Baseline, that's just my NVDA setting. It's reading the format, but what it means is just the text is in baseline. It's not superscript or subscript or whatever. But if now I go ahead and hit up arrow,
Page 1 baseline, x equals 2.
X equals 2.
X equals 2. X equals.
Yeah, so that's a pretty simple equation. Now what if we want to write something a little better? We want to include the 4 logical operators that actually come with our PC that we can use. So let's say x plus y equals 2.
Baseline. Page 1 baseline, spelling error, x plus y equals 2.
Spelling error. It's not what that essentially means. So it's reading the x plus y equals 2, but a spelling error because it doesn't recognize that word in the dictionary, because it's an equation and it doesn't really mean anything. That's why it's saying that. So that's a pretty simple equation. So we've done a simple equation, we've entered a simple number, we've covered the plus sign, the one of the first operators that we have without needing any external tool. Now, what if we want to do
x dash y equals 2 equal y x.
Actually, I'm gonna go ahead and
X plus y dash z equal 2. Page 1 baseline spelling error x plus y dash z equals 2.
yeah. So x plus y minus z equals 2.
X plan.
So that does it. So I'm gonna keep on adding to this equation.
X dash y dash x plus y dash z star a equals 2. Page 1 baseline spelling error x plus y dash z star equals 2.
Yeah, so x plus y minus z star a. So star, although this might not be this is not self-explanatory. It's usually used quite a bit to represent multiplication on Word when we're not making use of any external tools, and in this case NVIDIA does not announce that. So as you heard, it said star, but what it's supposed to mean is multiplication, right? So
plus y dash z out of step a star a equals 2.
so what that means is x plus y minus z into a, or multiplied by a times a, whatever works for you, equals 2.
Carriage return 2 equals a equals
And then
slash
what if I say b? Okay.
Baseline blank. Page 1 baseline spelling error x plus y dash z star slash d equals 2. Baseline blank.
So now that might have taken you a little bit more time to understand what it said that. So I'm gonna go ahead and read it character by character.
Page 1 spelling error x plus y dash z out of spelling error star a slash d equals 2. Baseline blank.
Yeah, so it should have made a bit more sense. What it actually said was x plus y minus z into a. Now slash b, so slash, it's one of the other things that is not self-explanatory at first, but what we commonly use to represent fractions. So if we say a upon b, or a slash b, that basically means that we're saying a divided by b, or a fraction where a is the numerator and b is the denominator. So those are the four symbols that come with us. They come with the on a standard keyboard in Word that we can use, and they might not look pretty at first, especially if you're making complex equations, which we'll get into later. But this, like I said, this is just the prerequisite knowledge that should be known, and you do need some whatever training with these things before we can get into the advanced part of it. And now it comes to the actual part that I wanted to talk about that many people are not aware of, which is the most important part that comes in handy for external tools, which is say if I wanted to represent something that's a little bit more complex. So in the equation above, we had x plus y minus z into a, or times a upon b equals 2. So in that case, it was a upon b, a divided by b. So, a fraction with numerator a and denominator b. But what if we wanted to say that the b there was in the denominator of the whole left-hand side, the whole LHS of the equation? How would we go about that? So a typical way of doing that is opening a bracket. So this was a round bracket that I just opened with Shift 9. So we could put it this way:
x plus y dash z star d d a right parent
close the bracket
slash d equals
2.
Page 1 baseline left parent spelling error x plus y dash z star right parent slash d equals 2. Baseline.
Yeah. So now it's the same thing, except it says left paren right paren, which is the parentheses. So in the parentheses we have x plus y
Page 1 baseline left parent spelling error x plus y dash z star right parent slash d
into a
equals 2.
upon b equals 2. So now that typically it is supposed to represent a fraction where the whole part, the x plus y minus z into a is the numerator and the b is the denominator. Now, what if I wanted to take this one step further and add something to the denominator? Now I could go ahead and do this.
Left plus y dash z out of a right parent slash d equals plus c left parent spelling error x plus y dash z star right parent slash spelling error b plus c equals 2. Baseline blank.
So I just added a c to the denominator there. So it's now upon the numerator upon b plus c. But this is not too clear. I mean, I used to do this a lot before when I first started working with math, with Word. This is not exactly clear. If someone's looking at your document, they don't know whether that b plus c is part of the denominator, like whether that whole thing is the part of the denominator or is just the b the part of the denominator, right? I mean, it's not really clear. Technically, like I said, since we wanted to denote the numerator, the whole numerator, and then upon that denominator, we used a bracket. So if you want to denote, so right now, as it stands, it technically, anyone looking at your screen would assume that only b is the denominator, since upon b and then plus c, which usually separates terms. But if I go ahead and use the same logic that I used above,
right parent, page 1 baseline left parent, spelling error x plus y dash z star right parent slash left parent, spelling error b plus grammar error c right parent equals 2. Baseline blank.
So now it's a bit more prettier, right? Now it actually says that the numerator that's in parentheses slash, which denotes divided by or upon, and then the denominator in parentheses. So now anyone looking at our screen would have a really clear idea as to what's going on here. That the whole thing is a fraction. So this makes working with, like, looking at your text, especially when you have, for example, you're using a screen reader and this is how you're typing it, and a sighted person looking at your screen, it would be way more easier for them to know what's going on without getting confused. So as I said, the use of brackets is one of the most integral skills that comes in handy for anyone working with maths, especially with screen readers, to represent stuff accurately. Obviously, like I said, the things we're writing here are gonna look way more prettier when we actually start making use of the tools that we have. But the thing is, as I said before, we're going to be utilizing these same skills that I'm pointing out here in said tools, and they're just going to make it look prettier and more specific and easier for someone looking at your screen to understand, and also improve the pronunciation rate, because right now it's not too self-explanatory. It's reading everything as it is, right? It says x plus y minus z in parentheses, left paren, right paren, and slash. So it's not saying that it's not telling you what you want to hear. I mean, you have to get in the habit of processing whatever it says. So you have to know that this is operating, this is adding, this is multiplying, and then there's a denominator starts here after the slash. So once we start making use of those tools, they're actually going to start pointing out what's numerator, what's denominator, what is being divided, multiplied, as well as make these operations look prettier. But for that, like I said, we should have a fair practice of the tools, or these few skills that I've been pointing out, which is why I made this video, although there's not a whole lot covered, and some of you might find it boring if you have already experienced all this and worked with all this. But I just thought it would be important for people to understand in case they haven't really worked with it, because I have seen a bunch of people who haven't. So before we actually end with this session, I wanted to point out a couple more things. So another symbol that is quite widely used is
caret.
This
page 1 baseline
caret, which is usually used to represent power. So if I say
2 caret 2, 2 caret 2,
2 caret 2, so 2 to the power 2, 2 raised to 2, so take 2 squared. So that's another symbol that we usually use. So we're going to now look at a couple more equations like these, except I'm going to make them a bit more complicated, and we're gonna go through the solution together, and we're gonna try to cover all the different tools that we have talked about until now, including all the different symbols that we have. So let's say
left raise,
I make this this equation
x left raise y caret 2 left parent z dash c right parent right raise right bracket equals 4 baseline.
So I'm gonna take it quite slow for this one and let you guys listen to this properly, as well as take a look at it.
Page 1 baseline left bracket x left raise y caret 2 left parent z dash c right parent grammar error right raise right bracket equals 4 left bracket x left raise y caret 2 left parent, Z, dash, C, right parent, grammar error, right brace, right bracket, equals, out of grammar error, 4, caret return, baseline blank.
As I said before, those grammar errors, spelling error, those things are annoying. You can actually turn them off in whatever screen reader you're using. Also, they will not be bothering us when we start making use of the more advanced tools. But so getting back to this problem though. So I'm gonna go to it again once more with the screen reader.
Page 1 baseline left bracket x left brace right, left bracket x left brace right caret 2 left parent, Z dash C right parent, grammar error right brace right bracket equals 4. Baseline blank.
Yeah. So this is considerably more advanced compared to the previous one that I covered, in the sense that we have multiple brackets involved, 3 of them in fact, and so we have multiplication done. So there's the x, which is multiplying with the y, and the y that multiplies the whole bracket inside, z minus c, and then on the right hand side we have
baseline blank. Page 1 baseline
right hand side value,
4,
which is 4.
blank.
So let's try to actually go over this. So let me say that
S O
we're
L U T O N.
beginning our solution here, so I'm gonna denote that.
Page 1 left bracket x left bracket x left bracket
Let's
bracket
copy
copy,
this
baseline blank.
over
Paste options
here.
data grid document blank. Page 1 baseline left bracket x left bracket
Yeah,
x
so
left brace y caret 2 left parent
so as I said, y caret 2. So caret denotes power, so y squared.
Z dash C.
So we have z minus c in a bracket, which essentially means, as I said, brackets are usually used to represent whole, when something entirely is being multiplied or divided, when it's not just one thing. Because in this case, if I didn't use a bracket, what that would mean is y is multiplying with
Z left parent
z, and then you're subtracting c from it. So basic bot math laws is what we're trying to utilize here.
Baseline page 1
So-
baseline left bracket x left brace y
We have y,
caret
and then
2
y
left parent
squared.
Z
So in here we have z.
left parent
So let's
Z.
get rid of this bracket since we're opening it now.
left parent 2 caret 2 Z
So y squared z
dash C
minus c. But
Dash
since y squared we're also
Dash C.
multiplying with the c,
y caret 2
we'll put that here.
2 caret y dash
So that
Z 2
Now
caret
this looks like
y left brace
this.
y caret 2 Z dash y caret 2 C right parent right
Perfect.
brace
I'm gonna go get rid of
Right
that
parent.
since we already opened the
right
bracket.
bracket equals 4 caret return baseline
Yeah,
blank.
so
Page 1 baseline left
Now
bracket
this
baseline
looks
blank.
like
Page 1
this.
baseline solution left bracket x left brace y caret 2 Z dash y caret 2 C grammar error right brace right bracket equals 4 baseline blank.
yep. So now we have the x
Page 1 left bracket
that's left. I'm gonna
left,
go
left
ahead and
bracket
copy
copy
this
Base-
because
blank.
that's gonna
Cut
be
copy paste
our
options data
next
grid document
step.
21 blank. Page 1 baseline left bracket x left bracket left x left brace y caret 2 Z dash y caret 2 C grammar error right bracket equals out of grammar error 4 caret return.
All right, let's
left
go
bracket,
over.
paste recovery data grid
So,
paste
like I
op-
said, as
baseline blank.
we
Page 1
did
left
before,
bracket x
this what essentially means is the bracket outside
left
x
brace
is multiplying
Y.
the
Left brace, Y,
entire
caret 2,
bracket
Z,
that
Y,
we have
caret
in
2,
here, the whole
grammar error right
thing
brace
that we just opened, which is why it's in braces. So, in gradually you'll get used to utilizing these brackets. It takes a while to get used to, but especially when you're working with big equations and when you're using the equation editor and latex and everything else that we cover later, these come in handy, and they help you avoid a lot of confusion. So before we get to jump to
out of grammar x left brace
these tools themselves after this video, I would encourage you guys to actually play with these tools if you haven't already, and experiment with them and try to solve some of your own questions that you have maybe in your textbooks with this. And I'll also be posting a couple questions in the comments later after we're done with the video just to make this more fun and interactive, and you can post your answer there.
baseline blank.
And we can give each other feedback, because like I said, this series is intended, like everything else on this channel, for us to learn from each other. Anyway, enough rambling. Let's actually finish solving this question.
Page 1 left bracket left brace x left
All
brace
right, so as before, we're opening this
Y.
bracket, so I'm gonna go ahead and
Left brace.
remove that.
x left bracket x y caret 2 Z dash
All right, so there's a minus sign there, which separates the term. So all I do is add the x there, just because it's multiplying with the whole bracket.
X,
So we have
y caret 2 C right brace right
there
bracket
we go.
right brace
So
baseline page 1 baseline left bracket z caret 2 Z dash z caret 2 grammar error C right bracket equals 4 baseline blank. Page
Yeah,
1 baseline
perfect.
left bracket
Now-
copy baseline blank. Cut copy paste options data grid
I'll
paste
paste
document
this once more
Set the paste
because
recovery data
I
grid
just want,
blank.
just
Page 1 base
for
left
the
bracket
sake
x
of
left bracket
clarity.
Page 1 baseline z caret 2 Z dash y caret 2 Z dash x y caret 2 grammar right bracket equals right bracket.
Since we're done opening everything, we no longer require those brackets, so our final answer looks something like
Base 1,
this.
page 1, base left xi caret 2z dash xi caret 2c equals 4.
Now, obviously, for those familiar with screen readers, it's not going to read those if they're in lowercase. It's not going to read them as it should. It's trying to make words out of them. So xi means xy, which is usually why when you're working with math, it's a really good idea to read char by char. Otherwise, there could be a lot of confusion.
X y caret 2 z dash x y caret 2 c equals 4.
Yeah, xy squared z minus xy squared c
equals
4. So that is our answer. Yeah, so that was basically a rough idea of the tools that we are going to be covering in this series, and these are basically the things that we're going to utilize. And obviously later on we're going to jump into some more advanced things like integrals and trigonometry, and but we'll get to those, and I'll be also trying to hand out resources as we go on. But this is some of the basic things that we're going to need wherever we go, whatever tool we use. So if you're not familiar with it, I hope this video helped you get a rough idea. And like I said, please do play with these things and try to get used to them. It might be a challenge for you otherwise if you're not familiar with these different skills that we covered. So anyway, that concludes this section of inclusive maths. This was a basic tutorial on word mass representation, which is considerably less prettier than it's going to be. Don't worry about that, as I said. And word is what we are primarily going to use until much later. So if you don't have Word, then I encourage you to go install that. Get the Word 2019 edition if you can. Also, this was with the NVIDIA screen reader, but JAWS also works perfectly well with it, and I have tested that. So if you are using JAWS, do not worry about it. It's completely fine. And so I hope you guys got to learn from this video, and I am going to be posting in the comments. So let's interact and let's see share with me whatever you learned. And if you like the video, then drop a like and let me know. And if you don't like it, then give me feedback, because this channel is all about feedback. And with that concludes the video. I will be posting a couple questions later. We're done, and we're done with this. I'll see you all in the next one. Stay safe, stay inclusive.